you can say that part 1 is differentiate log e bracket 1 plus e to the power of x, and hence find integral of that. You can have a look at the integral there. Okay, you don't really know what to do with that. Oh, the question was a little bit wrong. That will be 3e to the power of x. That's 3e to the power of x. That's a power of x. Okay, so what this question is asking first, let's say part A is differentiate that. Let's say fx equals to log e bracket 1 plus e to the power of x. And the f dash x will equals to g dash x over gx for log. Okay, logarithm g dash x over gx. So that's e to the power of x 1 plus that. Okay, so that's the f dash x. And part B. Okay, this question is somehow easy because let's have a look. The thing it asked me to antiderive is 3e to the power of x over 1 plus e to the power of x. It looks very similar to your answer. Can you see that? It's very similar to your answer. It's only 3 times difference. Okay, that's 1 times and the question is 3 times. So what you will know from part A is if you integral of this, okay, if you integral of this, that must give you like plus some constant. Let's just ignore the constant for a minute. If you integral of that, you will definitely have that, right? You from here differentiate to get f dash x. Integral f dash x must give you back the fx. Okay, so integral is like from the gradient function back to the original fx. So you will have that. But let's observe what we have and what is asking. What is asking is 3 times of that. So I can times 3 on both sides of the equation. I have set up an equation. Then I can times 3 on both sides of the equation. For example, like that. Well, the constant will still be like a constant. I don't know what is the constant. I can keep it like C. Or I can say there's a D, so 3D is a constant C. Okay, so it's just some constant. I don't know the constant, so don't worry about the constant. So the integral of 3e over 1 plus e to the power of x will give you 3 log e 1 plus e to the power of x. Okay, that's how you get the answer. So using the f dash x to find the thing asked in part B. So that's A, that's B. But this is a like really easy question. Okay, we start from an easy one. So that's the idea. Okay, integral of the f dash x will give you fx. Let's have a look at question 3. Okay, it asks me to differentiate x times e to the power of 3x. So part A is asking you to differentiate. So let's say fx equals to x times e to the power of 3x. Then the f dash x will be, okay, that's product rule. Okay, that's the product rule. We differentiate one times the original of another one plus times the original of that one and differentiate of the other one. So let's differentiate that first. That's 1. So we have e to the power of 3x plus x times, what's that? Differentiate of that is 3e to the power of 3x. So times 3e to the power of 3x. That's the differentiation. Okay, that's the differentiation. So what I will know is, okay, that's part B. Okay, it asked me to find the integral of that. Asked me to find the integral of that. But I don't really know what's the integral of that. We don't have a rule to work on this question. So we can just, okay, let's see, because it's a hands question, you know that's integration by recognitions. So the part B you will start with integral of the f dash x will give you that. don't worry the constant, so just leave your constant for a minute, it's alright. So you will have that. And let's have a look. This part. You don't need to worry about the constant because you can always times the constant on the integral, it doesn't matter. It looks very similar to that part. Okay, so my equation actually involves the thing what is asking in the question. Okay, so that part is same as that part. So that is what I'm asking for. So what I can do is, because that's something plus something, so I can integral them separately. So I can integral that plus the integral of that. It's always easy to deal with plus minus case in integrations and differentiations. So I can separate them into two integrals. And what is asking? Asking is the middle one. Can I evaluate the first one? I can, right? I have some rule to anti-differentiate that one. That is a third e to the power of 3x. Okay, integral of that, I can evaluate that part. That's a third e to the power of 3x. And I will still plus. I can put this 3 out. That's just a constant. Doesn't really matter. And I can subtract a third e to the power of 3x on both sides. So x times e to the power of 3x minus a third e to the power of 3x. And I can divide 3 on both sides. You just treat this part as a variable. Okay, I want to make that to be the subject. So I will divide. Why I need that? Because I want 5 times of that. Now I have 3 times of that. Then I will think, what is 1 times of that? So integral of x e to the power of 3x dx will equals to a third x e to the power of 3x minus 1 on 9 e to the power of 3x. Now what I want, it looks very similar to what is asking now. It's just 5 times of that. Then I can times 5 on both sides. Okay, I can times 5 on both sides. So that becomes 5x e 3x dx equals to 5 over 3 x e to the power of 3x minus 5 over 9 e to the power of 3x, and you can plus the c here. Okay, to integral that, I must know what is the differentiate. Okay, the differentiation on the top. So I must know the answer from part A, then I can do part B. Okay, so part B, that part involves what is asking. So the same as I'm solving for that. Let's say that's a capital X, I'm solving for my capital X. So I just move this to that side and divide the 3 and times the 5 on it. So what you have is that. So don't worry, let's say, why will you see an integral and you say, I can't find the antiderive of that. And you think, is that differentiation antiderive by recognitions? It won't be. It only be part 1 and part 2. It must be part 1 and part 2. So you really you don't need to know like when you need to use it. When you see A, find the differentiate, B, hence find something, is this method. Okay, is you using that way to solve for it. So that's example 3. Okay, let's have a look at example 4. Okay, example 4 is differentiate x times sine 3x. So if we have a fx equals to x times sine 3x, then the f dash x will be, okay, derive x is 1, so you have sine 3x plus, is that a plus, like x, leave x, and, okay, what sign will become? Cos, right? Sign will become positive cos for differentiation. So it's 3 cos 3x. Okay, hope you still can remember the differentiation. Sine will become positive cos and 3 in the front. So it's 3x times cos 3x. Okay, how you can know by another way that this is differentiation, anti-differentiation by recognitions? You see what it's asking is that it asks you this. This is part of the answer in your differentiation. So that must be using that method. So B, you will start with integral of the whole f dash x. You will have the fx. Okay, so the rule basically used here is integral of f dash x will give you fx. Well, plus c or not plus c, it's okay. You just need to remember to plus the c in the very end. So I will set up an equation first. And then we will have separate them. You must have one part can be anti-derived directly by the rules we have, and some part that we can't really solve for it. Okay, we'll have that. Okay, what's the integrals of sine 3x? Well, if this is what we want, then the other part can be integral directly. So what's the integral of sine 3x? 1/3 minus 1/3, okay? Sine will go for minus cos when you do anti-derive. So minus 1/3 cos 3x. Okay, you plus the 3 integral of that dx, and you still have that. You only want to leave the red box on the left hand side because that's your variable. That's what you want to make to be the subject. Then you move all the other things to the right. So 3 lots of that will give you x sine 3x plus a third cos 3x. And you divide the 3. X cos 3x dx equals to a third x sine 3x plus 1/9 cos 3x. And you already find the answer, so you plus the c value here. It just involves like moving the things around. Okay, fine. What is asking? Part of the thing is what asking. Leave that on the left hand side, that's your variable. You're trying to solve for that and move everything to the left. Okay, example 5. Okay, in example 5, see, they gives you d dx 1 plus sine x cos x over cos x equals to that. Why it is given to you? Because you must have a particular form of the f dash x in order to find the integral here. Well, if you like, it can be a lot of ways. Okay, your answer can be in multiple ways, in multiple formats. But like this is given, it means you must use that answer to get the integrals later. But let's show that first. So again, show that question. Even though the answer is given to you, you can't go backwards. Okay, you can't go backwards. You need to use your own way. So show all the workings to get that answer. I still see students like trying to use the answer in the showing question and to going backwards to show, oh, that's the same as beginning. That's not correct. So you find d dx. So because it's already giving you d dx, so do not set up another fx. Just write what is given to you. So just write what is given to you. And that equals to, that will be a quotient rule. Okay, that will be a quotient rule. So I will have cosine square x. And I put the cosine x on the top. And I will derive here. Okay, if I derive that, 1 becomes 0, sine will become cos x. So you will times another cosine x. Minus. Okay, minus. Now you need to derive the cosine x. Cosine x will become positive sine x. So you plus sine x times 1 plus sine x in the bracket. Okay, what I will have here is cos squared x plus sine squared x plus sine x. Okay, open the bracket, that's cosine squared, that is sine squared, and plus another sine x. What you will have over cosine squared x. What I should do next? Cos squared plus sine squared is 1. So what I have on top is 1 plus sine x. What I should do to the bottom? Well, what I need on the bottom is 1 minus sine. It's nothing to do with cos. How cos can become sine? Cos squared. I have cos squared. Like another question will be how cos squared can become sine squared. So cos squared plus sine squared equals to 1. Then cos squared will be 1 minus sine squared. So cos squared will be 1 minus sine squared x. But it still not looks the same. We are close to it. What I need to do next? How I can cancel? I can't do that. Wow, that's year 10 question, no. Yeah. Yeah, factorize. Okay, factorize. So 1 minus some squared. So difference of perfect square. Okay, difference of perfect square. So 1 plus sine x. I need a 1 on the top. I need to find some way to cancel the whole thing on the top. So I need to create 1 plus sine x times 1 minus sine x. Now I can cancel. Okay, now I can cancel that. That one and that one become 1 and 1. So therefore that is 1 over 1 minus sine x. One minus sine x. Let's have a look what it's asking. Okay, it's asking me to find it's asking me to find the integral of that. Can you see it looks actually quite similar to what we got already? But like what's the number? Like what's the factor in the front? You can take a 3 out, right? But how about the bottom? What we have on the bottom is 1 minus sine. But what we have here is 2 minus 2 sine. That's a 3 over 2. Can you see that? I must make it look like exactly the same as what we got. It's basically asking me to find that. I can take a 2 as common factor under the bottom, so that's a half. And the 3 on the top, so it's 3 over 2 as the factor. So I want to find 3 over 2 of that. 3 over 2. So integral of f dash x, I will have my fx. So that's a 3 over 2, 1 plus sine x over cos x plus c. Okay, integral of that, you know what is it? Any questions about that? That's 4 different questions. Like it's all on this type of question. I think it's quite important because like maybe every year there will be some question like that. Okay, there will be one question in part 1 exam like that. So it's quite important. Sometimes it even can be in the extended response. Some part of the extended response will have like this type of question. But like most of the time it will be part 1. Will be in part 1. Does anyone have any exams next week or SAC next week? What do you have? No, I just want to give some homework. No, it's 1 page. It's 1 page here. Just Saturday, Sunday. Well, let's say that if you don't have any test or quiz or like SAC, like let's say there's no SAC next week, just finish the 10 questions during the Saturday and Friday. If you have any SAC, do first 5. Do last 5. Okay, 6 to 10. 6 to 10. If you don't have any SAC, do 1 to 10. If you have SAC, 5 to 10. Okay?